Welcome, eighth video of design of machine elements. In this video, we will discuss about and what are the different material selection process. Aim of what is the aim of heat treatment? What are the various heat treatment steels? Okay, and once again, what is that BS standards of steels? BS standards of steels according to Indian standard high-speed tool steels designated some of designated numbers. Then we will see, we will recall it, and then we will move into that our heat treatment of steels. So with this, up to this videos, we learned how to design a product and what are the manufacturing considerations, aesthetic considerations of design. Okay, what is that ergonomics? We discussed. Now we discuss about Indian standards of designation of low and medium alloys. So we already discussed. Once again, we recall it. So we are having in this element and multiplying factor will be there. Suppose you take chromium, cobalt, nickel, manganese, silicon will be there. That is, we are going to multiplying with that element factor number is that 4, and aluminum, titanium, zirconium, molybdenum, all these things, metals, we are going to multiplying that element, multiplying factor 100, and nitrogen, sulfur, phosphorus, all the things we are going to multiplying with that 100. So now we take one example of this one. In this example, 40 Cr 4MO2 means the steel is having that average percentage of carbon in that steel is 0.4%. Another 1% is that chromium, and 0.25% is that molybdenum. So this is the designation of as per the Bureau of Standards of Steel. Another standard, Indian standard designation is for high-speed tool steel is according to the Indian standard. The high-speed tool steels are designated in the following order: XT. That is indicating that 100 times of percentage of carbon content. 100% of carbon content. So here, chemical symbol for alloying elements for each figure for its percentage of content rounded off to the nearest integer. So that here we will do that. Chemical symbol is to indicate, specify that added element to that attained desired properties. So what, for example, we will see that XT75W 18Cr 4V1 means a tool steel with average carbon content 0.75%, tungsten 18%, chromium 4%, and vanadium is 1%. So this is the things will be there. So heat treatment of steels, heat treatment of steels. So what is that heat treatment will be there. So now we will see that heat treatment of steels. So here, heat treatment, a combination of operations involving the heating and cooling process, means whenever we are going to giving that heat to that material, okay, the grain size, sometimes it is increased, sometimes it is decreased. So for that, grain size is coming together, very contact will be very close together, means the distance is very near. So the strength will becomes more. So the combination of operations involving the heating and cooling of the metal are an ally in the state for the purpose of obtaining certain desirable conditions or properties without the changing of the chemical composition. There should not be change of any chemical composition whenever heating and cooling process will be there. That heat treatment of steel. So what are the various heat treatment purposes? We will see that normalizing, okay, annulling, spheroidizing, hardening, tempering, surface or case hardening. Surface or case hardening. So these are the mechanical properties of a metal, mechanical properties of metal, all these things. So here we will discuss general things will be there. So those things we will discuss. So those things will be so now we will discuss heat treatment of steels. Now different various heat treatment process. We know that normalizing, hardening, annealing, tempering, spheroidizing, okay, and surface case hardening and tempering. So why we are going for this mm, heat treatment of steels? Why? What is the necessity to go for heat treatment of steels? So here, what is the main purpose? The term of heat treatment generally we are defined as the operation or combination of operations involving the heating and cooling the metal, heating and cooling the metal or any alloy in the solid state and the purpose of obtaining certain desirable conditions and properties without any change of chemical composition. So there should not be any change in that chemical composition whenever we are going to heating and uh, cooling. So some of the aim of heat treatment, why we are going for heat treatment is to increase that hardness of the metal. First point, to increase that hardness means strength of the metal. To increase that strength of the metal. So next, to relieve the stresses set up in that material after hot or cold working. Hot or cold working to relieve the stresses set up in that material after hot or cold working. Hot or cold working. So another one is to improve that machinability. To improve if that any hardness will be there, we are removing that one and machinability. It is very soft and cooling whenever we are going to that harder. So another point is to modify that the structure of the metal, structure of the material to improve the electrical and magnetic to improve that electrical and magnetic properties of that metal properties. Okay. Another one is to change that grain size. If that grain size is big, we are going to reducing that smaller one. So we have to change that grain size of the metal, microstructure of the metal, to increase that qualities of metal that provide um, better resistance to heat and corrosion. To avoid that corrosion, heat, and all these things also, we are going for heat treatment of steels and corrosion and wear. So what are the heat treatment process generally employed in normalizing? What is that normalizing? So what is that the main object of this normalizing is to refine that grain size, to refine the grain size. Mm, and structure of the steel, improve that machinability, tensile strength, and structure of the weld. Means to refine that grain structure of the steel. Why we are going for steel means to improve that grain size and improve that machinability and the tensile strength and structure of weld and the structure of the weld. To remove that strains caused by cold working process, okay, like hammering, okay, bending, bending, uh, etc., which makes that metal brittle and unbrittle, which makes it metal brittle and unbrittle. So another one more point to dislocations caused by the internal structure of the steel due to that hot working or cold working process. So to remove that dislocations, suppose any dislocations will be there in that grain size or rolling process, okay, any stresses is there, all these things we remove that stresses, we remove that dislocations, remove that internal structure of the steel, means we are going to keeping proper structure. Okay, for that purpose we are going for this normalizing to improve that mechanical and electrical properties, so then generally this normalizing consists of the heating of the steel from 30 degrees to 50 degrees. That steel we are going to giving heating above upper critical temperature hypoelectric steels. So we are going to higher temperatures also because of hypoelectric steels, we are going for higher temperatures. But normalizing means 30 to 50 degrees centigrade, we are going to heating that metal. And we are removing means so many things like hammering, rolling, bending, machinability, tensile strength, the structure of the weld, all these things, improving that mechanical and electrical properties. Okay, so all the things. So this generally this process is provides homogeneous structure. This process is provides for homogeneous structure consisting of ferrite and perlite, consisting of perlite, okay, perlite and ferrite, okay. This is for normalizing. So another one is that annealing. So another point is that annealing. What is that annealing? What are the objectives of annealing? We'll discuss. So the main objects of the annealing is to soften the steel so that it may be that easily machined. So we have to soft that steel. Why? Because why we are going to softening the steel? That can be easily machined. That can be easily machined. And to refine that grain size and structure, improve that mechanical properties. Improve that mechanical properties like strength and ductility. To refine that grain size and structure to improve the mechanical properties like strength and ductility, So that is that we have to improve that ductility of the material. We have to improve that ductility as well as machinability for softening of that material, we are going for annealing. So in this annealing, to alter that electrical and magnetic properties. Here also we are going to improve that electrical and magnetic properties. To remove that gases, whatever gases is entrapped in that metal, we are going to removing that metal during that initial casting. Okay. To relieve that internal stresses which may be caused by the hot and cold working process. Hot working process, cold working process, what are the stresses are induced? We are going to removing that one. Okay. Next, here in annealing, we are having two types of annealing. Full annealing will be there and process annealing will be there. Full annealing will be there, process annealing will be there. In purpose of the full annealing, to soften the metal, to refine that grain size, structure, to relieve the stresses and remove the tapered gases of metal. So the process consists of heating of the steel. So whatever we are taking the temperature over there, 30 to 50 degrees, same thing here also for full annealing. Upper critical temperature for hypoelectric steels by the same temperatures and above lower critical temperatures, that is that 720 degrees centigrade for hypoelectric steels, where we are going to doing for full annealing process. So another one is heating at the same temperature, the object, full annealing. The object of the full annealing temperature for sometimes enable that extended changes to take place. The time is allowed approximately 3 to 4 times for each thickness. Okay. Another cooling is slowly for that furnace. The rate of cooling varies 30 to 200 degrees centigrade. So now some of the temperatures we can see that in annealing process, less than see that table will give us for carbon content and annealing temperature. So less than 0.12%, that is called as a dead mild steel, 875 to 925. Another 0.1 to 0.45 mild steel, that is 840 to 970. So 0.45 to 0.50 medium carbon steel, that is 815 to 840. So another thing is 0.50 to 0.80 medium carbon steel, 780 to 810. So 0.80 to 1.50 high carbon or tool steel, 760 to 780. Okay. So that is a thing will be there for that annealing process. So another one is that process annealing. What is that process annealing? This process annealing we are going to using for this relieving this internal stresses previously set up in the metal for increasing that machinability and of the steel. So whenever stresses will be there, machinability is very difficult. Machinability will be that very difficult. Okay. So in this process, steel is heated to temperature below or close that lower critical temperature, held at this temperature for some time and then cooled very slowly. So this causes complete recrystallization in steels which have been severely cold worked, and a new grain structure is formed. So the process of annealing commonly used in that sheet wire industries. So this generally we are going to using this process annealing for to remove that internal stresses. Same temperature we are going to use 723 degrees centigrade. We are going to removing in that steel. Okay. So this metal. So when we are going to removing that stresses, machinability increases. Corrosion is very less. means corrosion effect will be that less. And heated to that below closed critical temperature, very we are going to heating low critical temperatures. So sometimes we are cooling very slowly. So complicate for recrystallization of steels whenever we are going for low temperatures. Okay, with this I'm stopping this video for analyzing. Next video we will see that remaining heat treatment processes. Thank you.